All right, let's look at how we can classify what kind of triangle we have based on side lengths when we're given coordinates of the vertices. So we're going to be classifying by side length, so just a reminder that whenever we classify by sides, there are 3 different possibilities we have. So the first possibility is that it is equilateral. And in an equilateral triangle, all 3 sides are the same length. The next one is isosceles. And in an isosceles triangle, 2 of the sides have the same length, but the third one has a different length. And the final classification is scalene, which is where all 3 sides have a different length. So we're going to use this set of points, and we're going to classify what kind of triangle this would be based on its sides. So the way I do this is I'm going to use my distance formula. And the distance formula is the square root of a squared plus b squared. A is going to be the difference in the x values, and b is going to be the difference in the y values. So let's start with side JK. So if I'm looking at side JK, I'm using the coordinates for point J and point K. So using these coordinates to figure out what A and B are, I want to see how many units are in between each set of x values. So between 1 and 2, there's 1 unit between them. So in my formula, that's going to be 1 squared. To find B, I look at how far it is between my y coordinates. So between -2 and 3, that is 5 units. So this is 5 squared. So the length of JK is going to be the square root of 1 squared plus 5 squared. So 1 plus 25, which is 26. So the length of JK is the square root of 26. So now let's look at our next set of points. Let's look at KL. So if I'm looking at the length of KL, I'm using the coordinates for K and L. And I want to find those distances again. So first, I'm going to look between my x values, -2, or +2 and -4. So to go from +2 to -4, that is 6 units. And 3 to 3, that didn't move at all, so that's 0 units. So in my square root, it's going to be 6 squared plus 0 squared. So when I add these together, 6 squared is 36, and the square root of 36 is 6. So the length of KL is 6 units. So far, I can rule out that it's an equilateral triangle because JK and KL did not have the same length. But we have one more side to find. So no longer equilateral. So our last side is going to be JL. And to find the length of JL, I use coordinate J and L. And then I find distances. So distance between 1 and -4 is 5 units. And the distance between -2 and 3 is 5 units. So when I plug this into the formula, I do the square root of 5 squared plus 5 squared, or 25 plus 25, which gives me 50. So the length of JL is the square root of 50, so I can tell that it's not going to be the same as any of these. So this has to be a scalene triangle. But also, if you're trying to figure out what the side length is, you might want to go on and put this in simplest form. So the square root of 50 can be reduced. and it can be reduced by the perfect square 25. So I'm going to change this to 25 times 2. So the square root of 25 times the square root of 2 is the square root of 50. And then to reduce that, 25 is a perfect square, so this reduces to 5 root 2. So the three lengths, JK, KL, and JL, are all different, which makes this a scalene triangle.